Hi, good afternoon. I'm Jennifer Priestley. Thank you so much for coming to my talk. I'm going to go ahead and share my slides and get started. So again, I'm Jennifer Priestley. I'm a professor of statistics and data science, and I'm going to be talking about how to demystify data science for executives and talk a little bit about not just data science and the evolution of data science and why you might be struggling with taking full advantage of the data scientists within your organization, but also talk a little bit about how we got to this point and introduce a little bit about how universities are thinking about data science as an academic discipline and how we're producing the next generation of data scientists coming into your organization. So before I get started, just a few things about me. So from 1989 to 2000, you can see a little bit there about my background. I was primarily in a combination of financial services and in management consulting. And then in 2000, I did a hard shift and I went back to school and I got my PhD. And I've actually been in academics ever since. So you can see I spent 21 years so far in academics aligned with the university. Prior to that, I was in the private sector for 11 years. So I've had an opportunity to see data science from both sides of the coin, both from the standpoint of a practitioner and from an organizational perspective, as well as from an academic perspective. And I can tell you that that crossing that Rubicon from the private sector into academia was not a trivial one. The vocabulary and the philosophies and really just the metrics of success and the way people are thinking about some of these questions and some of these topics, specifically in the analytics space, look very different on the private sector side than they do on the academic side. So after now, gosh, almost 30 years of working, I started working when I was 6. After 30 years of working, I'm going to share a little insight into the differences between the private sector and academia, and hopefully that'll give some insights into how you can get the most out of your data science talent. So like a good academic, I'm going to start with a pop quiz. So my first question is, what percentage of analytic insights will ever actually deliver expected business outcomes? So I'll let you guys kind of populate that in the chat. And then the follow-up question is, what percentage of big data projects fail? So again, I'll let you guys kind of answer those questions and put those in the chat. If we were doing this in person, I would have you shout out your answers. So depending on your source, the answers to these questions are about 20% of analytics insights actually ever deliver any expected outcome, and about 85% of big data projects fail. So, so what does this mean for executives in organizations? It means that unfortunately, a lot of the investments that we're making as a society, and certainly within your own respective organizations, is just not generating the return on investment. And so, again, kind of depending upon the source that you look at, there's a long list of reasons why that might be the case. But there's really kind of 4 main themes as you look across all of these different articles as to why data science and AI investments fail. You can see that first point there is not having the right talent. And when we talk about the right analytics talent, we're coming to this problem very organically and very honestly. A big part of the problem is we haven't truly defined what it means to be a data scientist. So we have everything from the person who was the poet on Friday and took a Python boot camp over the weekend and then changed their LinkedIn profile on Monday to reflect data science, all the way up through the PhD in computer science who already has multiple patents under their belt. So part of the issue here is actually defining what it means to be a data scientist. The second point there is solving the wrong problem with the wrong tools. And I'm going to talk about data science tools in just a minute, and why sometimes we're using the wrong tools at the wrong time to solve the wrong problem. within our own university, it's amazing how many organizations will approach us and they'll say, I want to use TensorFlow to solve this problem. And we say, well, hang on. TensorFlow may or may not be the right tool in the context of this problem. Let's talk a little bit more about defining what that problem looks like. But this is a common problem within data science, where particularly those that have really strong computational skills want to use the most complex tool possible in order to solve a problem. We may not necessarily need deep learning if the problem can ultimately be solved with a dashboard. So, so the second thing we see very frequently is solving the wrong problem with the wrong tools. You can see that third point, not having the right data. So we're awash with data, but the question is it actually the right data? So, we hear a lot of noise within the data, but are we ultimately able to detect the signals within the noise? And then finally, that fourth theme that we see as to why data science and AI investments are failing is not considering the wider societal impacts. So data science as a discipline is very much facing a lot of the same questions that the healthcare industry faces in terms of ethics and in terms of AI, and in terms of really sort of what does it mean to have a Hippocratic oath? I won't do harm. So just because we have the data and just because we have the skills does not necessarily mean that we should be building the model. Or if we are building the model, do we fully understand what the implications of this model are across the wider society? So, again, executives across the continuum are seeing a lack of return on the investment in data science and AI. And, these are kind of the four themes that we're seeing in this space. A lot of organizations now are increasingly turning to universities to possibly be part of the solution to achieving more of a return on that investment. And what does that look like? So you can see a couple of the little snips that I've put up on the screen. And if you're a massive organization like IBM, you might be able to spend $240 million to partner with MIT. But if you're a smaller organization, or if you're an organization that maybe necessarily hasn't done work with a university in the past, what does that look like? And how can you potentially work with a university in order to address some of these pain points and get the most out of AI? And then what does that even look like? What does data science look like at a university? And ultimately, who would I even call to get started? And so, this question is not simple. It's not a simple one, because universities are these big, complex organizations with lots of different schools and colleges within the organization. And when we talk about data science and artificial intelligence and partnering with a university to help solve some of those pain points, where would I even call to get started? Is data science housed within the College of Business? Is it housed within the College of Computing? Is it housed within the College of Engineering? Is there even a school of data science? And again, the answers to these questions are not simple, and they're not trivial. Well, before I tell you about where data science is housed within a university and how that is going to be used to inform some of these pain points that you're seeing in terms of your data science and AI investments, it probably makes sense to provide a little bit of context as to how we got to this point. So when we talk about the kind of the evolution of data science and what data science looks like today, I think it's important to stop and take a look at how data has evolved. So historically, data has been what I'll call small, structured, and static. So when we go back to as early as the 50s and the 60s, when we first started collecting data in any meaningful way for the purpose of analysis, it was what we would now consider to be small, structured, and static. And so, you can kind of think about, now Excel spreadsheets. And this is why data science at its very core really started in statistics. Statistics is very much the origin of data science, in large part because our first steps in learning how to analyze data, how to translate data into information to solve problems, started from data that kind of sits in this box. that's small, structured, and static. And so when data kind of reflects these specific characteristics, the types of analysis that we're doing would be kind of categorized today as descriptive statistics and predictive modeling and classification. And if that is all you need to do, then to be honest, you're not going to need a data scientist. This is just where, very simple analytics can probably save the day. But as data has progressed from being small, structured, and static to being large, unstructured, and in motion, now we're not just talking about traditional statistics and traditional analytics. Now we're talking about this integration of statistics with computer science, and we're talking about having to deal with sensor-based data and IoT data and machine learning. And again, from an academic's perspective, this is where we really start to bring in information technology and computer science combined with statistics and combined with some of those business disciplines. But of course, data is not just large, unstructured, and in motion anymore. Now we're talking about data that's massive and integrated and dynamic. And of course, this is where we're starting to talk about systems of data, talking to systems of data, which is now leading to these conversations around artificial intelligence and deep learning. And this is where we start to get into, again, some of these wider societal questions around, should we even be building these models? And if we do build these models, do we fully understand what the implications of these models are? And so it's interesting that we're kind of transitioning from just looking at statistics and computer science and information technology. Now, as we move up into this upper box in terms of the complexity of this data, now we're kind of bringing back in the humanities, and we're talking now about sociology, and we're talking again about ethics, and we're talking about human system interactions. And so the point of this slide, tying back to why you might see some challenges in terms of solving some of your data science and AI investment pain points, is that data science has evolved in this very messy, complex way as an academic discipline through statistics, computer science, information technology, physics, engineering, and now again bringing back into the equation the humanities and ethics and sociology. And so importantly, when we talk about how universities are thinking about this, it comes back to the previous slide about where would you even find data science at a university? Is it going to be housed in computer science? Is it going to be housed in statistics? Is it going to be housed in the business school? And so again, the answer to that question is not simple. So, the title of this talk is Demystifying Data Science. And so, data scientists are all about the methods, right? About how I'm actually analyzing this data. And, so for all of the conversations we have around all of the different things that data scientists do, at their core, data scientists really do kind of 5 key things, right, in terms of the methods that they use. They're using some combination of linear regression, logistics regression, decision trees, random forest, if they're dealing with supervised modeling, if they have some kind of target that they're trying to model against, or they're dealing with some combination of principal components and k-means clustering. Really, at the end of the day, these are the 5 key methods that everybody in data science is learning. And at some level, this is really what practicing data scientists are using in their day-to-day jobs. So, from an academic perspective, when we teach these things in the classroom, what is the framework? How are we educating students in learning these techniques and actually applying these when they come into your organizations? So, very simplistically, here's a list of the very traditional data science methods, kind of an iteration of the previous slide. And, what I like to tell my students is, let's start at the top with something as simple as like a t-test or just comparing means. And then let's only get as complex as we need to based upon the needs of the problem and based upon the needs of the data. And so, I don't want to scare you with this very complex decision tree, but this is really conceptually at some level how data science is taught within a university. And so where we start is, let's talk about the variables. How many outcome variables do we have? How many things are we trying to predict or explain or control? What kind of outcomes do we have? Do we have continuous data? Do we have binary data? Do we have ordinal data? And then you can see as you move through each one of these questions, ultimately it will drive you to whatever that data science method is that you're going to need to be applying to the question. And so if we go back to the original slide where I talked about these pain points, why are data science and AI projects failing? Why are executives not seeing a return on their investment? A big part of that is, not having the right talent, but it's also not applying the right tool to the right problem at the right time. And so this is a framework that I think a lot of key data science programs that are really taking data science as an academic discipline very seriously are trying to use in order to ensure that we're producing talent ultimately that will help make sure that those pain points are being mitigated. One important point, again, that I want to make here is that we really emphasize only go as complex as you need to and not more complex. So I made the point, let's not use a deep learning neural net. Ultimately, if we can solve this problem using a dashboard, or if we can solve this problem just using some kind of basic comparison of means. And so, that's not a trivial issue that we communicate in the classroom. So, kind of going back to the point about, kind of where would you find these skills? Where would you find data science? Where would you find analytics at most universities? So, here's my next series within the pop quiz group. So, I'm going to let you guys put these in the chat. Where do you think most programs are housed at universities? Are they housed in the College of Business? Are they housed in computing? Are they housed in engineering? Are they housed in some kind of interdisciplinary center or institute? I'll let you guys put a couple things there in the chat. So, the answer probably is not surprising. It actually is heavily varied. So some universities are choosing to put data science, analytics, machine learning programs in the College of Business. Some are putting it in College of Computing, Math, Stat, Engineering. And then increasingly universities are putting data science into this concept of like what I like to call academic Switzerland, into a center or an institute that sits outside of this traditional siloed department or college environment within a university. And that's actually, I think probably the best place for data science to sit, because at its heart, data science truly is an interdisciplinary academic discipline where faculty and students within a center institute have the ability to work with organizations from all across the university. And of course, that's more common and parallels what happens in the private sector. So, when we talk about the different types of people that are holding these jobs, there are some subtleties to this, right? So we talk about people that are more aligned with an analytics, data analyst, business analyst, operations analyst, and that tends to be more closely aligned with the business disciplines. So if you are looking to bring in talent that's more closely aligned with analytics, you're probably going to be better off talking to the business school. If you're looking for people who are more aligned with like research and scientists, people that hold those titles that you see there on the right, those are going to be the more computational disciplines. And so you're probably going to be better off looking within a university in more of a College of Computing or in mathematics and statistics. So, kind of putting a little bit more clarity around that, again, how universities are thinking about this, we can think about it in terms of hubs and spokes. So for universities that are really using the model on the left, we'll call that the hub model. And so in that context, students are coming into a university program, whether it's at the undergraduate, master's, or PhD level, and they're really studying data science as like their major, right? So they are truly being trained to be scientists of data. And then they would have some area of application, be it healthcare, finance, marketing, manufacturing, biology. But the point is that their emphasis is on data science, and then they have these different areas of application. This is in contrast to models like on the right, where students are pursuing what we might call more of a spoke model. So this is where students are studying like finance, or they're studying manufacturing or something in the social sciences, and then they're picking up an analytics course or two along the way. So the model on the left, these students are going to be very computationally sophisticated. They're going to be able to understand and explain, hopefully, what's happening inside sort of that black box of these data science algorithms, right? They should be able to explain the math and the programming, be able to directly interpret those coefficients, and really explain what's happening end to end. But the downside to that is that because they're so computationally focused, they're potentially going to be losing some of the nuances and vocabulary that is going to be part of being in the healthcare industry or being in the finance space. Again, in contrast to the model on the right, these are students that are going to be majoring in finance or marketing, business or biology, and then they're going to be picking up a class or two in analytics. So these are the students who are going to have the domain expertise, and they're going to understand the vocabulary and the nuances of the healthcare industry versus the finance industry. And then they're just going to have some basic working knowledge of analytics. So they may not necessarily understand what's happening inside that black box, but they can interpret those results within the context of the business problem or whatever the research problem is. So neither of these models is necessarily better or worse. They're just very different. And so again, if you kind of go back to one of those early slides where I talked about the pain points, why do executives have so much trouble seeing a return on their investment from their AI and data science projects? And that number one point was having the right talent at the right time. Well, I think understanding, where is this talent coming from? Is it coming from a model that really looks more like the programs that are going to be on the left? Or is this talent coming from programs that are more aligned with the model on the right? Again, neither of these are different. It's just ensuring that you have the right talent at the right time for the right project. So, at their core, universities, if you want to think about universities kind of farm systems for your talent, universities do kind of two things, right? I mean, for all the things we like to beat our chest about, at the end of the day, we do two things. We teach and we develop new knowledge. That's what universities do. And so, in terms of working with organizations in the analytics and data science space, there's kind of 4 manifestations of teaching and developing new knowledge that we see in terms of collaborating with private sector companies. So the first is, sort of the obvious, right, is we help to create pipelines of talent. And that goes back to some of the points that I was making before about how we're approaching data science as an academic discipline and how we can create pipelines of talent, be they data science talent or be they analytics talent, depending upon what you're looking for, creating pipelines of the right talent at the right time for your organization. The second point there is collaborative research and innovation. PhD programs in data science are really starting to emerge in a deep and meaningful way. At our university, we actually launched the first PhD program in data science. And when we launched that program at the PhD level, we thought long and hard about where these students would go and what they ultimately would be doing with their degree. And we recognized very early that about half of the people that are going to be pursuing a PhD today are planning to go into the private sector. And so we want to ensure that they can engage in collaborative research and innovation with private sector partners to ensure that that is part of their doctoral level training now. Historically, that wasn't the case, but certainly if you look at PhD programs today in data science, this is very common. That third point, faculty workshops and ad hoc training. So, we hear topics now around, computer vision and knowledge graphs. And, the reality is unless you're just constantly taking courses online, you're probably not up to speed on all of the current thinking in data science. And so partnering with the university is a great way to do some spot training with your organizations. And again, making sure that you have access to the most up-to-date tools and the best tools to solve the problems that you're facing. And that then is carried into that fourth point about upskilling resources. So again, you know, data science is a fairly nascent discipline. And if you've graduated more than 10 years ago, chances are that data science wasn't even offered at your university at the time that you went through school. And so universities are a great place to collaborate, to upskill, you know, again, your employee base. And so again, these are kind of 4 ways that universities are working with organizations in order to solve these key pain points that have been identified as why organizations are not seeing returns on their investment. So, you know, again, when we talk about, you know, what the landscape looks like for analytics and data science practitioners, we can see that there's undergraduates, masters, and PhDs. And you can see the differentiation there. At the undergraduate level, you're more likely to see people going into analytics versus data science. And I think this probably makes sense. I mean, data science as a heavily computational degree probably is not a great undergraduate degree. Certainly any undergraduate who's willing to listen to me, I tell them ultimately if they do want to go into data science in any deep and meaningful way, they probably should pursue an undergraduate degree in mathematics and applied mathematics or in computer science or potentially statistics. You can see there in the middle, the majority of people that are engaged in analytics and data science have a master's degree. It's probably not surprising that you see a higher proportion of masters going into positions called analytics versus data science, where the majority of people with PhDs ultimately are going into those data science positions. Again, these are very computationally rigorous degrees, and these are the people that are really doing innovation and research within these organizations. Okay, so this brings us to the next question in our pop quiz. The skill that is most commonly included in job ads for analytics professionals is, I'll let you guys kind of type these in the chat. So, you know, here's the long list of skills and then the disciplines there, analytics, business analyst, and data science. And you can see those distributions. And I know this is a bit of an eye chart, but at the end of the day, the most common one is communication and interpersonal skills. And in fact, that's the #1 that's required in job ads in analytics and business analytics. But it's still more than half for data scientists. So of course, you know, what does that mean for universities? Well, what are we actually teaching? So if we look at a distribution of credit hours, you know, certainly at the master's level, you know, you can see all the kind of usual suspects, but teaching soft skills is actually really hard. This is a really hard thing to do, really teaching those interpersonal communication skills. I can tell you it's really hard to do in the classroom. So the primary way that we do that is by partnering with organizations in the private sector through the context of capstone courses and analytics project courses, research labs. That's really where students have an opportunity to work with organizations and really build those communication skills and really learn how to communicate technically rigorous concepts to a non-technical audience. You know, that really is the coin of the realm in these analytics programs. So I've been working on a book that actually is now coming out in the next couple weeks in conjunction with Robert McGrath from the University of New Hampshire. And we talked to you know, a series of different companies, and we talked to a series of different universities, all of whom are heavily engaged in analytics and data science. And we actually have come up with kind of a summarized checklist of how executives can partner with universities to solve some of those pain points. So you can see my first point there in our summarized checklist is start with a program director. So being in analytics or data science, certainly at the master's level, program director is almost a full-time position. So you think about how do I even get started talking to a university? Go look on the website, because chances are there's going to be a program director that you can reach out to, and it's actually their job to work with private sector organizations to tie their students at the undergraduate level, master's or PhD level with organizations, again, in the private sector. I'd like to say that projects, I have a specific highlight here around master's level projects, but projects in general, when you're working with analytics and data science programs, should be in what I call the Goldilocks zone. So they shouldn't be so simple that students can just knock it out just like they would a homework assignment, but they ultimately shouldn't be so complex within your organization that the students can't ultimately be successful. And so again, the program director can help you kind of think through what those projects should look like for students. Remember that graduate students are ultimately not consultants. So if you are going to be working and partnering with the university, and as part of that, you're going to be developing these capstone courses or these project courses, just remember that these are students and this is a learning environment. And it's a great way to build the talent pipeline. But while they're still students, just remember that they are students. We're sponsorship of an undergraduate program. Undergraduate project course is probably going to be free. The funding expectations for master's level projects tends to be in that kind of $5,000 to $15,000 range per semester, depending upon who you're working with. And it's really going to require a lot more funding if you want to partner with a university at the doctoral level. And to be clear, these funds are not going into the faculty's vacation fund. This is used to offset faculty salaries and faculty time and pay research stipends, importantly, for the students. And then finally, certainly if you're going to be partnering with the university in the context of research and publication, just know that this is really critical and important for the students, for the doctoral students, and even for some master students. And the rules of engagement on publication, if you're going to be doing any kind of partnering, need to be established up front. And note that your legal department is always going to start out by saying no. But there's almost always an opportunity for a mutually beneficial outcome related to publication of findings. So this was really intended to be a fairly quick summary of how universities potentially can be used to help address some of the pain points that you're having in terms of seeing returns on your investment in data science and artificial intelligence. And I think I've gone a little bit over time, but I'd be happy to potentially answer any questions that you guys have in the chat. So thank you. All right, well, great. Well, again, I think I went a little bit over. I have a big digital footprint, but I'll put my email in the chat and feel free to reach out to me if you have any follow-up questions. Thank you.